Hi guys.
Did you share the recording for last class?
Ma, you have to go check, ma. Please read the welcome email. Go check how to see the recording and all. If you don't find it, only you have to come and ask.
Okay.
Okay, it is important that you go read the email, how to do, get it, and then if you don't find, then come and ask, ma. Okay. Okay. Mm. Hi, Dia. How are you?
Good. How are you?
Oh my gosh. I'm good. How are you, Mitra?
Hi, Auntie. I'm good. How are you?
You were traveling, right? A lot?
Yes, Auntie.
Okay. You're back in your place or still traveling?
We're back now, but we're going to India soon.
Wow, for another month?
Yes, Auntie.
Oh, that's lovely. Okay, let's go ahead. See, last week we were discussing combinations, and there was one more we discussed, right? What was that? Complementary counting, right? So today I want to discuss probability, general probability, along with, if possible, a couple of problems on casework counting. Let's see. Hey, Tanisha, did you move? Oh,
Yeah.
you're in Texas now? Good to know. Very good to know. Are you liking Texas?
Yeah.
Oh, nice. So completely done from the old place?
Yeah, pretty much.
Where were you, Ma?
Portland.
Oh, Portland. Yes, yes, yes. So how's the climate there? You like it?
Yeah, it's fine. I mean,
Okay.
it's more sunny.
Nice. Did you go to
Few
school?
places. No, school starts in about next week. Next week, yeah.
Oh, okay. Did you check about the math curriculum that you're going to go through?
Yeah, I looked at it. Um,
Mm-hmm.
it says that it gave us three options. We can take seventh grade, we can take accelerated two, or we can take algebra one. There was a form. We couldn't do anything. We selected algebra one, but I think my parents emailed the counselor asking about how we can take geometry.
Nice. Okay. Let's go ahead. Okay. So, so you know the general probability. Let me go ahead and do. We want to discuss probability, right? What is probability? Chance of something in our favor. Let's say probability of an event. Let's consider this event as, let's consider tossing a coin. Tossing a coin, in that, my event is tossing a head. So, tossing a head is a favorable event. Right? So, here, tossing head is a favorable event. So probability of that event is number of favorable outcomes divided by the number of total outcomes. Any questions? Any questions here? So favorable outcomes divided by the total number of outcomes is what is the chance? Chance is probability, right? Now, sometimes if you are asked the probability of an event happening, right? We might have to find out what are the cases in which our favorable event can happen. Then you have to find the total number of possible events. You have to divide by that. So let's see this one. I pick a number from 1 to 10. Let me write it down. Here, when you think about events, probability, all this stuff, right? I really want you to understand a couple of things. There are dependent events, there are independent events. Meaning, I just told you about tossing a coin. Tossing a coin is a simple event. Okay? Simple event in the sense, you just toss a coin. That is a simple event. Do you know what are Compound events, ma? Tanisha, do you know what are compound events? Compound events in the sense, do you know what are compound events?
I believe it's where there are two events.
Yep, more than one simple event.
Yeah.
Now, more than one simple event, it can be toss a coin. Toss a coin. See, there are two things that you're doing. You toss a coin, toss a coin. You toss a coin, spin a spinner. It can be anything. Okay. Or, okay, let's say a kid is born, a kid is born in a family, then another kid is born in a family. So, do you see? It can be any event and an event. So, if that is the case, then we get to compound events. When it comes to compound events, it becomes very complicated. Probability becomes very complicated until you understand things. So, coming to compound events, they can be dependent events or independent events. Let me give you examples, then you'll quickly understand what is the difference between dependent event and independent event. Let's say I toss a coin, spin a spinner. I'll first tell you an example. You have to come out telling me how they are different. Dependent events are, what example can I give you? Okay, red, blue, green, balls in a bag. Okay, pick a ball, again pick one more ball. Why? Why these are dependent? Why this is independent? Coming to independent events, the first, the first, the first experiment that I'm performing is tossing a coin. For that, this is called the sample space. What is a sample space? Sample space, see, I'm squeezing everything together. So it's like just giving you facts. Just giving you facts and big definitions. Sample space is a collection of all possible outcomes. Any questions there? Now, this is the sample space for this. Spinning a spinner. Maybe the spinner has 1, 2, 3, 4. If it is the case, sample space is 1, 2, 3, 4. Is there any relationship? Is this anytime dependent on this? No. Got it? Now, picking a ball, again picking a ball. Let's say you picked up one ball. Okay? You picked up one ball. Fine, 1 out of 3 you picked up. Okay? But again, picking a ball, do you see the number of total balls in the bag reduces to 2 balls? This was 3. Let's not put in colors. Now, first you pick a ball. Now, the state of the bag changes to only 2 balls. So, before the second event, meaning by the time the second event happens, the state of the bag is not the same as was earlier. So, depending on what color ball you pick, the probability of whatever you pick second will change. Basically, the second event is dependent on the outcome of the first event. These are dependent events. Where the outcome of the second event is not dependent on the first event are independent events. Any questions raised? You have to be on the video. Otherwise, I'll move you to the waiting room, please. Shreysh, are you there?
Yeah.
Okay. So dependent events and independent events. Any questions? Okay. Now let's go ahead and see this one. Okay. How about this? It's a good one. You're going to try this out, okay? I'll talk about the scenario. I am choosing a number from 1 to 10. You get to choose a number from 1 to 25. What is the probability? First, think about dependent. See, when you come to probability, you have to think. First, you have to think about whether the events are dependent or independent. Okay. Now, what is the probability that the product of the numbers is odd? Of the two numbers. Right. Is odd. You want me to try or you want to try? Shall we try together or do you want to try, guys? First of all, the two numbers should be odd, right? What should happen? Mm-hmm.
Is the answer 13/50?
Ma, send it, Amma.
Oh.
Everybody is working, right? Mm-hmm. Diya, Sresh, Tanisha. Correct, Ma. Mitra, I'm waiting for your answer. You want me to do it on the board? Did you get it, Ma, Mitra? Almost done. Okay. Okay. Others, right? You don't have to wait. Let's see. Mitra, you can continue. Let me know. Otherwise, I'll do it for you. How about this? A person rolls a die with the numbers. This is a little tricky. If you want, I can give you clues. 1, 1. See, if you solve it very easily, then we'll go a step up. 1, 1, 2, 6, 15, 30. And another person rolls a die with the numbers 1, 2, 4, 18, 28, 44. What is the probability that the product? It's very similar. Do you see the problems? What? But the second one is a tad bit difficult. What is the probability? The product of the two numbers is a multiple of 24. Mm, that's a good try though. Mitra, that first one is correct, ma. You can go ahead and do the second. Can I give you some clues, guys? It's a little tricky. You don't want clues, Tanisha? Okay. I'll wait for another minute and then give you clues. Done, ma? Okay. Tanisha has the answer. Huh? Good job. Do you want to explain, Tanisha?
Okay.
Mm.
So in a column, I wrote down.
Mm.
I made a
You made a tree. Okay.
tree
Mm.
diagram with the first dies numbers, so 1, 1, 2, 6, 15, and 30. And I
Mm.
just quickly wrote down everything else. Then I
Mm.
just looked at which pairs had multiples that made 24, like 6 and 4. If those multiples were present, then it would make 24, or 3 and 8. Stuff like that.
Let's say, okay. So in a column, I wrote this. Okay. In the
Yeah.
next column, I have a different way. So I welcome your way as well. Go ahead. Mm.
Okay, so I just like going off from each one, I wrote 1, 2, 4, 18, 28, 24 for each one.
Mm.
And then I just looked at which pairs had 6 and 4 in their multiples, or 3 and 8.
6 and 4 in their multiples, or 3 and 8. Good job.
Yeah.
So 24 factors. So 124, or it can be 212. You didn't consider 212?
No, I didn't.
3, 8, 4, 6. So where can that be? You have to find multiples of 24, right? Which one will it be here? None, right?
None.
Good.
Except for
And
one.
then same thing here, right?
Yeah.
How about this?
2s don't work either.
Mm-hmm.
6, we have 3 of them. 4, 28, and 44 work because you have the pair 6 and 4, and 44, 28, and 4 are all multiples of 4.
Mm-hmm.
15 doesn't work, and same with 30, 4, 28, 44, because 30 has 6.
4, 28, 44. Good job. So you have three options, right? Six
Yeah.
six possibilities, six
Out
ways.
of 36 combinations.
Yep, 6 out of 36 is 1 by 6. Why 36 in here? These 6 favorable events divided by the total number of events can be, so there are 6 in here, 6 in here, 6 times 6, 36 possibilities are there, because 6, each of them have 6, right? 6 times 6 is 36. So out of the 36 possibilities, 6 basically, um, 6 out of 36 is the probability that two numbers picked. Uh, I'm sorry. That the product of the two numbers is a multiple of 24. Any questions? Did you get it? Can I move on, Sresht?
Yeah.
Okay. Okay. How about this is an easy one. We did see, basically you did independent events. Okay. Let's see. how about this? First, you need to decide, okay? Remember, the base is dependent independent events, okay? After that, it's not hard. Tree diagram always helps. Let's see. If you need a clue, definitely message. These are easy based on whatever concepts we read. So I'm giving it to you. Let me know, but if you need help. They finish in random order. What is the probability that Chase is first, George is sixth? Let's see. What do you think? Is this dependent or independent probability, guys?
Dependent.
Dependent, yes. Not a hard one. After this, meaning, just reiterate on how to find out probability on independent and dependent events. It's not a hard one, I tell you. It's an easy one. Very easy one than anything else. Done. Tanisha, yeah. Sresht. Not really. So this is dependent probability, okay? Yeah, definitely it is dependent. Chase is first, George is sixth. Order does not matter. So what is the probability here? What is the probability of Chase coming first? One of you tell me, what is the probability of Chase coming first?
Well,
One
six.
seven. One
Or
seven.
1-7. Sorry.
1-7.
7. Now, Chase already came first. Exclude him completely. Because George coming sixth is dependent on this. What is the probability George is coming sixth?
1-6.
1-6.
1/6. So that's it. Both has to happen. Chase
One.
has to come first. George has to come sixth. 1/7 times 1/6 is 1/42. So from here, we wrap up this concept where for finding the probability of independent events, probability of A times probability of B gives you the probability of both occurring. Make sense? For dependent events, where B is dependent on A, right? Like this one. This one is an example. In this case, probability of A, B happening would be probability of A times probability of B given the fact A has occurred. Any questions? This is called a pipe symbol. So they're completely different. You have to make a note of, for the second one, right? Probability of B. How to find the probability of B? Given A has already occurred. You have to assume that A has occurred and then you have to find the probability of B. Any questions? Any questions? Okay. Can I move on? Okay, what next? This one is a tough nut. If you want me to explain, I'll explain. Otherwise, I think I'll explain this, I feel. Let me see. On Saturday, there is, guys, you have to clearly let me know quickly, okay? On Saturday, there is 20% chance of rain. On Sunday, there is 30% chance of rain if it rained on Saturday, but only 10% chance of rain if it didn't rain on Saturday. What is the probability that it will rain on both days or neither day? Can I explain or do you want to try? Ma, you have to be interactive. Ma, anything is okay with me. What should I do? Should I wait or continue to explain?
I'm gonna try.
You want to try? How about you, Mitra, Dia, and Shrestha? Hey, I value each of your opinion, guys. You have to talk
Not
though.
sure.
You want to try? Okay. Mitra and Dia?
Yeah, I want to try that again.
Sorry, okay. 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 But let's set up a timer like, okay. Otherwise, I'll not finish, I feel.
Did I get it right?
Yeah, I have to check. Okay, wait. I don't know. Hold on. 1 minute. Yeah. 1 second, guys. You have not studied. It's okay. Yes, ma, Tanisha. Perfectly great. Did you change, Tanisha? Why did you change, lady? That's right still.
I made an error, so I changed
Yeah,
it.
no. You just changed the fraction, right? Equivalent fraction, right?
Yeah.
Yeah, that is correct. Both are right. I'm sorry. I did not notice that they were equivalent fractions. Okay. But fine, ma. But what is the probability? Oh, they didn't tell you whether to find it as a percentage or a fraction. Okay, you are right. Answer is right. So I cannot question you on that. I thought it was asked for percentage, so it's good. Okay. So 5 times 5 times 5. Mitra, somewhere we are losing. Yes, Dia. Good job, Dia. Okay, guys, I really want you to show a trick, meaning show a way where you won't make mistake with this, okay? So do this, okay? Saturday, Sunday, no confusion, okay? These type of problems are very common and you can do this. I think this one is a MCAT problem. So here, rain, no rain. Please do this, guys. You won't make mistakes at all. Rain, no rain. With no rain, rain, no rain. Saturday, there is a now on Saturday, there is a 20% chance of rain. So this has to be 80%. Then on Sunday, there is a 30% chance of rain. Then I'm sorry, on Sunday, there is 30% chance of rain if it rained on Saturday, but only 10% chance of rain if it didn't rain. You see what I mean? So you just get this filled in. What is the question now? Question is, what is the probability that it will rain on both days? First of all, how will it rain on both days? This one. Both has to happen. It will rain on both days. Means what? 20%, 30%. You have to multiply 2 by 2 by 10 with 3 by 10. That is, it rains on both the days. Right? But then on both the days, or it doesn't rain on both the days, or you can add this probability with it doesn't rain on both the days. That means what? 8 by 10 times 9 by 10. So what is it? 6 by 100 plus 72 by 100. 78 by 100, which is 78%. Any questions? This one is the deal breaker. Okay, when things become confusing, you will never get confused if you can draw this way. Can I move on?
Auntie, did you add both of them in the end?
Okay, why? Good question though. What is the see, it will you can account for it will rain on both the days or it doesn't rain both the days. So two probabilities can be added here, meaning your favorable events are two different things in here. One is it will rain on both the days. It won't rain on both the days. There are two different things that are favorable events. You see what I mean? So this one is rain on both the days. This one is no rain on both days. You see? Both are our favorable events. You see? Did you understand, ma? But for it to rain on both the days, this should be multiplied with this because both has to happen. If both has to happen, you multiply like independent events.
Yeah, actually, I said
Okay. But if, okay, let's see. Now I'll see whether I have a problem similar to that. Yeah, I do, but I don't know. Let's see. This one is a hard nut. I don't see. Hmm. How about this? You want to try this because it's similar, but it's not similar too. If you want me to help, definitely let me know.
I can't see half the problem.
You can see, ma. Okay.
Okay, now I see it.
Okay. There's a 40% chance of rain on Saturday and 30% chance of rain on Sunday. Tanisha, you're going to 7th, Amma. Okay.
Yeah.
40% chance of rain on Saturday and 30% chance of rain on Sunday. However, it's twice as likely to rain on Sunday. Please do the diagram. It's very easy. Meaning very easy. See, another thing is this 30% chance of rain on Sunday is a tricky wording. It's a very tricky wording. What is added to get that 30% is a tricky wording. 40% chance of rain on Saturday is easy. You can put it directly. 30% chance of rain on Sunday is very tricky because that 30% chance of rain on Sunday can be with Saturday no rain or rain. That's a deal breaker in this question. See, wordings are so important, I feel. Okay, let me see how many more problems did I plan. Yeah, I planned a lot. Let me see what we do. Hmm. Tanisha, not really. I told you, right? It's a hard nut. But try, meaning it's just the wording that's so confusing. I will start writing. You don't have to see, but I will explain once you allow me to. There's a 40% chance of rain. This is a very common type of problem. Not only in MCA, whatever competitions you attend, it's common because these are dependent events which are really confusing. This is clear. From this, whatever I have written down is clear. 40% chance of rain on Saturday is clear. The next one is the biggest issue. Sunday. However, it's twice as likely to rain on Sunday if it rains on Saturday. So this one is X, this one is 2X. Rain. This one is again rain. 2X, I'm going to put it as percentage because everything I'm putting it as percentage. Now, no rain. I don't know.
I sent a new answer.
Is that, I don't know. 1 minute. Did I note down the answer? No. That my answer doesn't coincide with yours. Let's see. We don't know this one, okay? No rain. The thing now is, this I understand from here. It is twice as likely. Red means I'm marking them as red. So from that red color wording, I have written down whatever I inferred. The next one, there's a 30% chance of rain on Sunday. Rain on Sunday is this and this. What is the possibility of rain on Sunday? 40% times 2x% rain on Sunday. Or rain on Sunday can even be 60% times x%. Any questions? This is 30%. Am I making sense? This and this get added to 30%. So now 40%, 40 by 100 times 2x by 100 plus 60 by 100 times x by 100. So what is this? 1, 1. So I take that off. 2, 5. So this one becomes 4x. You know what? Yeah, 4x by 500 plus 3x by 500 equal to 30 by 100. So this will become 5. So 7x by 5 equal to 30. x equal to 150 by 7. Any questions here? Now, let me go ahead and substitute 150 by 7. Does that make sense? Does that make sense? 150 by 7 is x. When I want to convert it to percentage, becomes 150 by 700. 2x percentage, x is 150. So this is 300 by 700 basically, right? Yeah.
How'd you get that?
Bottom ma? Okay. Which one ma? Conversion?
The value of x.
Okay, let me redo. See, this is the trick, right? 40%. I just solved this. 40% times 2x percentage plus 60% times x percentage equal to 30%. I can explain, wait. Shreyas, you got it. 1 minute, ma, Tanisha. Okay, let me go through again. What I'm saying is, the chance, see, 30% chance of rain on Sunday. Rain on Sunday is what? You can have rain on Saturday and then rain on Sunday. That is one possibility. You can have no rain on Saturday and rain on Sunday. Make sense? Both will contribute to rain on Sunday. So, for it to rain on Saturday and rain on Sunday, it was 40% for Saturday. Then this is 2x percentage. Make sense, Tanisha? For it to rain on Sunday, you can have 60%, meaning no rain on Saturday and rain on Sunday, which will be X percentage. Am I making sense?
Yeah.
Yes.
This contributes to rain on Sunday whatsoever. How to evaluate this? Percent means I don't know, meaning some of you are not attending my class, right? So usually what I say, percent means divide by 100. That's all. Wherever you see percent, you're going to substitute it with division by 100. So this is 40 by 100, which is 4 by 10 or 2 by 5. Now this is 2x percentage means 2x divide by 100. Here 60 by 100. Percent means divide by 100. That's all. Per cent. Per means divide. Cent means 100. 60 by 100 is 6 by 10. 3 by 6. I'm sorry guys. 6 by 10 or 3 by 5. Times x percentage is x by 100. So that becomes 4x, 3x, 7x by 500 is equal to 30 by 100, right? So now x equal to 150 by 7. Am I making sense?
But how'd you get equals 30 by 100?
It's given, right? 30% chance of rain on Sunday. There's 40% rain on Saturday probability. We don't know about Sunday at all. The total probability of chances of rain on Sunday is 30%. So what are the factors contributing to rain on Sunday? You could have had rain on Saturday, rain on Sunday. Or you can have no rain on Saturday and rain on Sunday. That means these two cases add up to 30%.
I don't get how you would understand that it means that there's a total combined chance of rain on
Sunday.
Sunday, 30%. How do
That
you
is the trick here, ma. That is the, see, clearly it's worded. Only thing is we need to read 30% rain there and a 30% chance of rain on Sunday. That's all they've given, right? So rain on Sunday means these two are the factors that contribute to rain on Sunday. So that adds up to 30%. See that another thing, Tanisha, they have we meaning this tells me I'm waiting to make equations. This tells me it is twice as likely to rain on Sunday if it rains on Saturday. That means there is some x involved there, some unknown involved there, and I need to multiply it by 2 for to tell me the percentage of rain on Sunday if it rains on Saturday. So that's why I assume this as x, this as 2x percentage. Everything I'm putting it as a percentage for the probability. So I put it as x percentage and 2x percentage. Does that make sense? Okay, so x is 150 by 7, then what? This is more, this is a bigger problem. So if it is 150 by 7, your x value is 150 by 7. So please substitute and find out what is 2x percentage. What is x percentage? X percentage is 150 by 700, right? So it is 15, 3 5s are 15. No, I'm sorry, 5 3s are 15. 3 by 14. This is 3 by 14. Yeah, and that one, the next one is 2x means what? 2 times 150 by 7, right? That will also be 2 times 700. So that would be
3 by 7.
14 3 by 7.
Oh,
I would not want to do that. Can I put 6 by, can I, meaning, I want my denominator to be nice and clean. So can I put 6 by 14? Now, what is asked is entirely different. The probability that it rains at least one day this weekend. See, okay, now we are only halfway through. They're asking the probability that it rains at least one day this weekend is A by B. What and all you have to add, guys. I have clearly written down. Okay, let me write it down nicely if you want to. 1 second, guys. I'm going to make this a better picture. We need to do this properly. Okay, 40%, 30%, right? Saturday, Sunday, 40%, 60%. I'm sorry. This is rain. This is no rain. We are not yet done for sure. This is what was something? Can you tell the
6
numbers?
by 14.
6 by 14, right?
Yeah,
This is 3 by
3
14,
by
right?
14. Yeah,
So this would be 6 and 6, 6, 12, 8 by 14.
8 by 14.
This would be 11 by. Yep. Now, what are they asking basically? Probability that it rains one day this weekend. What all you have to add? The probability that it see again words, guys. The probability they did not ask the probability that it rains one day. They asked what is the probability that it rains at least one day. There also there is a catch. What I need to add?
You
Come
need
on.
to add all of it.
No.
You need to add the chance that it rains on only Saturday, the chance that it rains on only Sunday, and the chance that it rains on both Saturday and Sunday.
So let's call this rain. 1 minute, Amma. What and let me put it as 1, 2, 3, 4. Which and all you want to add?
1, 2, and 3.
1, 2, and 3. Correct. Correct. So 1, 2, and 3, meaning it's not that easy when you look at it, right? So one thing is you don't have to make it that hard. You're going to add both of this, right, Amma? Meaning both the scenarios you need to add, right? So the best way is 40% times 1 because these both add up to 1, right? Plus 60% times 3 by 14. That's all. So this will be 4 by 10, which is 2 by 5 plus this one would be 2, 3, 6, 5, 9. 9 by what is that? 22 minus 5, 6, 7. Yes, 1, 5, 15 to 30. 39 by 70 maybe. Did I make it correct? Oh no, I didn't do it correct. 70. 5, 4s are 20. What I'm doing, 5 ones are 5, 5 4s are 20. 2, I have a 28 here, really? 28 plus 9 by 70. Did I make sense? 1, 4, 14 times 2, correct. So 28 plus 9 is 30, 7 by 70. So you add them together, answer is 107. Well, does that make sense?
Yeah.
Okay. It was a hard one. But you know what? This is not an AMC 8 problem. It's an AIME problem. That's why, see, but you see the concept that you study in AMC8 builds up to, I think it's an AIME problem. So it's a harder version, but the base comes from AMC8.
That question.
Yeah. Okay. How about this? Let me write it down for you. I have 5 cards in a box. 5 cards in a box. You try this one, okay? This is not a hard nut, okay? 5 cards in a box. Maybe we'll put in numbers and we are selecting 3 cards without replacement. Select 3 cards without replacing anything. Think about different ways of doing this, okay? Okay, now what is the probability that 4 is the largest value selected? 4 is the largest value selected. We are just discussing probability, basic probability, largest value selected. But not all problems are very easy. Like what you do in geometry is very easy.
The last round selected.
Hmm?
The last.
Oh, sorry. 4 is the largest value selected. Thank you. Did you get it?
You must be feeling very sad.
You want me to put, oh, Tanisha, you have got the answer. See, sorry.
Did I get the answer?
Tanisha, yeah, Dia, that is correct, Dia. Good job, Dia. Tanisha, you want to try once more? You're there, but you missed something. I don't know what you missed. I'm not able to understand still, though, honestly. Something you missed. You are there, though. Wait, Tanisha, did you calculate 3 choose 2 incorrectly? Okay, check. Okay. No, I'm wondering where you might have made the mistake. Shrestha as well, you're there, but I don't know, somewhere something is missing. Why don't you explain, Shrestha? It's okay to go wrong. Go ahead and explain. Let's see where you went wrong.
So there are 5 ways. There are 5 cards, right? So there's 5 factorial ways to like order them. Or
Yeah, but the order, yeah.
and then 4 comes 24 times, so 24 over 120 is 1/5.
Oh, you did that. Seema, okay. You don't, the order is not important, right?
Oh yeah.
You see what I mean? Here, it's not, order is not at all important. So it's all combinations.
Oh, okay then.
Because you left duplicates, right, Amma? At the end.
Yeah.
Mm. Good. Anybody else you want to explain and clarify? Dia, why don't you explain, Dia?
So first I did 1 second. My work's all over the place.
Sure. No problem. Take your time. Did you get it, Tanisha? Okay, why don't you explain, Tanisha? We'll see where is the error.
Okay.
It's absolutely okay, Tanisha. If I make a mistake, you're going to pick next time. Go ahead.
There are 5 cards, and selecting 3 without replacement would mean you have 5 solutions, 5 possibilities for the first one, 4 for the next, and 3 for the next, which 5 times 4 times 3 is 60. So there's 60 possibilities. Then
1 minute, ma. 5 cards in a box. It's 5 choose 3, right?
yeah.
Is the formula n factorial over n times n minus 1 factorial for combinations?
For combinations, Amma, combinations is, see, first of all, let me put that. N factorial by n minus r factorial, right?
No, that's permutations, right?
By r.
Yeah, R.
Tanisha, it can't be 5 times 4 times. The order is not important, right, ma? Yeah, so 5 choose 3, right, is the total number of possibilities, right? You have 5. You're choosing 3 of the cards, right? You're selecting 3 cards. So 5 choose 3 is 5 factorial by 3 factorial 2 factorial, correct, ma?
Yeah.
So this will be 4 times 5 divided by 2, which is 10, right, ma?
Yeah.
And then what is the probability of 4? Okay, now the total possibility we found out. But in this, 1, 2, 3, 4, 5, we definitely chose this. Don't worry about it at all. We definitely chose that. Now we need to find out. You cannot choose this. And you are given 3 options. You choose 1. So 3 choose 1 is 3 factorial by 1 factorial, 2 factorial is 3. So favorable events, the number of combinations of favorable events is you can pick 1 and a 4, 2 and a 4, 3 and a 4 basically, right? Oh, you're picking 3. So you have to, so 4 is already selected, right? So you will choose, you have to choose 3, choose 2, right? So if you choose 3, choose 2, there are only 3 ways. So answer is 3 divided by 10. Make sense?
I don't understand why the method I use doesn't work, so I
Okay,
don't.
let's go ahead. Let's go ahead with your method. Go ahead, Ma. Go ahead, Tanisha. What was that?
So I found 60 possible combinations, and then oh, okay, now I understand. Now I understand.
Yeah.
Because
Yeah,
my
you did this. You did this, right?
yeah.
But okay. Here, if you do this right, you're calculating the permutation. You have to do the
Yeah, I see
combination.
that now.
Got it? Okay.
Yeah.
Okay. I'm going to stop here and ask you for 1 second, guys. Vishrank, did you have any questions? No, not really. Okay. Now, guys, I will give you a bunch of homework. But see, this one, a last one seems easy. Two different, okay, let me give you this. -2, -1, 0. This one is very similar. That's why I thought I'll do this one last one. Okay, this one is very similar though. So you start identifying similar type problems, okay? Then you have 3, 4, 5. I have this bunch of numbers with me. -2, -1, 0, 3, 4, 5. In this bunch of numbers, two different numbers are picked up and multiplied together. What is the probability that the product is 0? What is the probability that the product is 0? Two numbers are picked. It's very easy, meaning it's very similar. So if you understood that, I'm assuming everybody should answer this correctly. Two different numbers are picked. Probability that the product is 0. சொல்லு. Sorry, I was talking on mute. Did you get it, guys? ஒரு நிமிஷம் இருங்க. Done.
Is my answer correct?
Is your what was your answer? Wait, do I have an answer? Let me check. Otherwise, we'll do together. You Sresh, you just missed on some small thing. Can you check? What did you do? What did you do for the favorable events? What did you do? This was an AC problem.
I did all the things that multiply up to 0.
How many are there? I say okay. So
There's
what are the favorable events?
5.
See, but two different numbers are picked up, right?
Yeah, so because there's 6 options. Wait. Yeah, there's 6 options.
Yeah.
But then you have to choose 2 different numbers. So you can't choose 0 and 0.
See, 0 is the only number you should not choose, correct?
2 different.
Okay, product is 0. Okay.
Yeah.
Let me calculate in a way product is not 0. When will product not be 0? If you choose 5, choose 2. You have only 5 numbers, you have to choose 2. That means you're excluding 0, right?
Yeah.
So 5 choose 2 is the number of ways that are not favorable. Correct?
Yeah. Wait, this is a combinations problem, right?
Yeah, combinations problem. 11 out of 25 lemma. Okay, let me show you. Okay, what are the total number? I'll do it and finish it off. What is the total number of what is the total number of possibilities? Let me tell you. Tell me, guys. Two different numbers are picked up from a lot of 6. What is the total number of total? What is the denominator?
15.
6.
Yep, 15 I felt, right? Yeah, what is that? 6 choose 2, right?
Oh, yeah.
So 5, 6, 2, so 3, 15. Now, favorable. See, the thing is, product is 0 means it's favorable ways. Not favorable ways. What are the, when will the product not be 0? If you choose 5, choose 2. Not favorable ways. 5 choose 2. What is 5 choose 2? 5 factorial by 2 factorial, 3 factorial, right? 5, 4, 3, 2 goes 2, 2, 10. 10 non-favorable ways of the 15. So for you, the product to be equal to 0, it's 5 out of 15, which is 1 by 3. Make sense?
Yeah.
Okay, we'll stop here. Prishang, did you understand that?
Yeah, I got
Tanisha?
it.
Okay, Tanisha, Dia?
Yeah, I got the solution.
Good. Okay. So I'll do one thing. I have a lot more problems. I'll send to you. Okay. But regarding after this will be the last class, right? For the fall classes, I have not even rolled the registration form. I know I came back home only yesterday night. Okay. I just want these classes to happen on Tuesday, Wednesday, Thursday, all the makeup classes. And I'll be circulating the registration form this week. But I honestly, at this point, I don't know whether I'm going to do MC8. Okay. But discuss with your parents and let me know if you want to do. Please ping me with a private message. Based on that, let me decide. Okay. Okay, guys, that's it. What else? Do your exams well. If we meet, great. If you don't meet, definitely do it well. Go over all your previous AMC8 problem papers. Okay, that is going to be of immense help. 100%. Understand how to do. Even if you re-engineer from the solution, understand how to do, and you should be able to identify same pattern problems easily. Okay. So we did see algebra counting probability we did maybe 50%, I would say. Not okay. Algebra we didn't touch, but geometry we did a lot of it. So at least try targeting all the problems in geometry, probability. Algebra is an easy one that you already have done in school. That's what I am believing. Other than that, number theory, it's okay. It's okay even if you are able to scratch the surface with number theory. So do well, guys. All the very best. Okay, if we meet, we meet. Let me know after discussing with your parents. Just ping me with a private message, whatever it is. Okay. Okay, guys. Any questions? If you don't have any questions, we'll log off.
Thank you.
Okay, good luck with your school, guys.
Thank you.
Bye, guys.
Thank
Bye.
you. Miss Priya, I had a question on the homework.
Which one, ma?
Wait. I think it was the similar triangles one.
Similar triangles. Okay. Can you send me the problem? Why don't I solve and send it to you? Is that okay?
Okay. Yeah, that's okay.
What is the problem? Meaning, let me know. Let me know the number right away. I will note down and I'll solve it right away and send it to you soon after this class itself. Or give me
Okay.
1 minute. If I don't have a kid that's coming in, I asked a kid to come in at 9:15. If he's not coming in, great. I can work with you. Let me see. Wait 1 minute. Huh? I'll check. One minute, Amma. Yeah. Okay. I think they'll come. Ma, tell me, Vishang, what is the problem, ma?
Question 8.
Question 8, homework clear. Was it in the homework, ma?
It was in similar triangles. I forgot.
AMC 8 class. Question number 8. Let me quickly check.
Mom, can I watch something today?
Yeah, you can. Vishang, shall I solve it and send it to you right away?
Yeah, sure.
To your mom's ID, can I send it?
Yeah, sure.
Okay, ma. Anything, any other questions you had? Wait. But let me read out the question to you. Just confirm and then you log off, then I'll send it to you. Wait.
Okay.
Uh, first, let me stop.